Welcome to day 8. You got 2019 part 2, number 5 and 6. Make sure to do that on a separate sheet of paper. And then you got the pink packet where you were working on multiple choice, 76 to 92. Those are calculator active multiple choice. So kind of like last Wednesday, check your answers for the multiple choice and then skip ahead and only watch the explanations of the ones you got wrong. Or if you guessed, say, on one and you didn't really know how to do it, you can watch the explanation for those too. And then after you watch the explanations for the multiple choice ones, skip to the end and watch the explanations and the answers for the free response. So you can pause the video here so you can check your answers and then play it and skip ahead. So for 15, there was a couple different ways we could do this. One, under our radical, that's the derivative squared plus 1. So the derivative squared must be 9x to the 4th, meaning our derivative, our dy over dx, has to be plus or minus 3x squared. Take your antiderivative, you get x cubed plus c. And if we sub in our point of 1 comma 6, our c would have to either be plus 5 if we had the positive x cubed or plus 7 if we had the negative x cubed. So based on the choices, b is the one that we have. The other way you can do it is you can go through the choices and do your derivative squared plus 1 and just see which of those would match up. You could also sub in the point 1, 6. 1, 6 would eliminate c, d, and e, and then you would just have, it would eliminate c and d, and then you would have to do derivative squared plus 1 for the other three. So you could work backwards from the choices if you wanted. So because the point of tangency is at x equals 1, f prime of 1 will equal the slope between any 2 points on the tangent line. So you can just do change in y over change in x, and you get this, the slope is 3 for those 2 points on the tangent line, so that must be the same as the slope at x equals 1. So choice C. So if you do your dx over dt and dy over dt, we get 3t squared for dy over dt, 2t to the 2t minus 4. If you set 8 equal to the original y equation, that's 8 equals 2 cubed, so cubed root of that is just 2. So the only option for t is for t to equal 2. If we sub in 2 for t now, we get 12 over 0. So that means we should have a vertical tangent line. And vertical lines are x equals some number. Since we're passing through the point negative 3, 8, we need it to be x equals negative 3, so choice A. Your derivative of g, this is your second fundamental theorem of calculus. You would sub 2x in for t and then multiply by its derivative afterwards. So g prime of x would be f of 2x, then times the derivative of 2x, which is 2. We want g prime of 3, so we're really doing f of 6 times 2. Now, f of 6, on the graph, I would say it looks more like negative 0.9-ish, but if you did negative 0.9 times 2, that's not a choice, so the best choice there would be the negative 1 times 2 to give you negative 2, so choice C. So take your antiderivative, because the slope was 2x plus 3. You have your plus c on the end, sub in your point 1 comma 2, you get c is negative 2, and then put that back in for c and you get choice D. In 20, we want to recognize we got all the factorials, they're all positive, so we want to be thinking e to the x. Well, e to the x you can see is written there, but our exponents are always 2 more than our denominators. So we're going to have to multiply by an x squared at the end, but that front term would have originally been x squared over 2 factorial. So the 1 and the x are taken away. So we need the e to the x, take the 1 and the x away, and then multiply by the x squared. So when it distributes through, that gives you choice D. In 21, our basic differential equation for a logistic, we have some value k times whatever our y value is, so m in this case. Then in parentheses, it's the carrying capacity minus that m again. So we had to pull out a 1 over 200 from everything, and that would have left us with 200 minus m inside the parentheses. So that means our carrying capacity is 200, so as t goes to infinity, m should approach that value of 200. In 22, we need that denominator exponent of p to be more than 1 greater. Because if you think of a p series, if it's just 1 over n to something, p had to be greater than 1. So we need p, because the numerator degree of n is 1, we need p to be more than 1 bigger than that, so we've got to have it be greater than 2. So choice E. 23, you had to do integration by parts. Remember our choices for u, lipit, logs, which we don't have, inverse trig, which we don't have, polynomials or monomials, which is what we do have. So our u is going to be x, the dv will be sine 6x. When you do your antiderivative of the sine 6x, remember to do a correction by 1/6 out front. You have your uv. When you do minus v du, you can pull the negative 1/6 out front to make it a plus 1/6. And then just do your antiderivative of the cos 6x, which has a little correction of 1/6 from a u substitution, and you end up getting choice B. In 24, any value of sine stays between -1 and 1. Pi is 3.14, so the inside of that parentheses, the absolute value will be less than 1. So that's going to converge by geometric. In 2, by p series, because p is greater than 0 but less than or equal to 1, 2 is going to diverge. And limit as n goes to infinity in the third one. Think of like ratio of the leading coefficients, that plus 1 is not going to make a big deal when n goes to infinity, so that's just going to approach 1. So by nth term test, that's going to diverge. So choices 2 and 3, or in other words D, are ones that will diverge. So you're just doing a right-hand Riemann sum. So you had a gap of 3 times the right-hand y value of 28, gap of 5 times right-hand y value of 34, gap of 4 times right-hand y value of 30. Add them all up, we get choice D. 26, you had to do partial fractions. So I didn't show that first step there, but initially you have the 2x over x plus 2 times x plus 1 equals a over x plus 2 plus b over x plus 1. Then after you multiply through, that's what we would get. Pick your strategic values of x to find a and b, and then once you have those, you can do your antiderivatives. These will always end up being natural logs. Remember, if you had a coefficient of x other than 1, you would have a correction you'd have to do when you do that antiderivative. So choice D. For 27, we're taking the derivative. This is our second fundamental theorem of calculus again. Fill in the x cubed. So we end up getting x to the 6 plus 1 in there, and then you have to multiply afterwards by its derivative, 3x squared, so we eventually get choice E. If we want an x squared, the coefficient of the x squared term should be the second derivative at x equals 0 over 2 factorial. So you've got your original function. Think of that as 1 times 1 plus x to the negative 2. Do your first derivative. There's technically a chain rule where we multiplied by 1, but that doesn't affect anything. Do your second derivative. When you sub in the x equals 0, you get 6. So our coefficient should be 6 over 2 factorial, which is the same as saying 3, which ended up being choice D. Moving on to the free response. So these were both no calculator questions. They gave us our integral from -6 to 5, and we wanted to find the integral of -6 to -2. Well, the integral from -6 to 5 would just be our integral from -6 to -2 added to -2 to 5. Well, we know on that right-hand side there, they told us that was 7. For that second integral, the -2 to 5, we can just do it with areas. That first triangle is above, it's got an area of 1/2. The second triangle below is -3/4. Then you've got the triangle from 0.5 to 2, that's 9/4. And then for the part that's under the quarter circle, think of it as you got to do a square that's 3 by 3. So that's the 9. And then you're subtracting off the quarter circle, which is 9 pi over 4. If you combine your like terms, that's 11 minus 9 pi over 4. If we subtract the 11 over and add the 9 pi over 4 over, that gets the integral from -6 to -2 by itself. In B, we want to do integral from 3 to 5. So do your antiderivative would just be 2f of x plus 4x. If we sub in the 5 and the 3, f of 5, if we look at the graph, is just 0, so that becomes 2 times 0 plus 20, then minus, and in parentheses. This is why they told us the point at 3, so 2 times f of 3, which was just 3 minus radical 5, and then you had the 4 times 3, which gave you 12. Distribute your negative and combine like terms, you get the 2 plus 2 radical 5. So for the third time on this homework, we see the second fundamental theorem of calculus. Take the derivative of g, which is just f of x, and it's times 1 technically. F of x is equal to 0 at -1, 0.5, and 5. So those need to go on our number line, as well as the -2, because that's where our interval started. Make sure to label your number line. On the top, it either needs to say f of x or g prime of x. Either of those are fine, and x on the bottom. Just based on the y values in the graph, you can get your pluses and minuses. We are looking for the absolute max. So we need to find the relative max and test that as well as the endpoints. So our relative max ended up being at x equals -1. Make sure you tell that it's because either f of x or g prime of x switched from positive to negative. So g of -2 is our integral from -2 to -2. Well, that's just 0. G of -1, which is where our relative was, we're going from -2 to -1. Well, that's just a half of a block above the x-axis. So you get a half there. And then from -2 to 5, our other endpoint, that is, that's what we already found up in part A. The -2 to 5 was that part that's in the parentheses there, the 11 minus 9 pi over 4. So 9 pi over 4, if you just think of pi as like roughly 3, that's 27 over 4, so that's 6 point something you're subtracting off. 11 minus 6 point something is the biggest of those ones there, so that's how you get that's the absolute max without having a calculator. And our last one, our limits, we're just subbing in. 10 to the first is 10. F prime of 1, if you look at the slope of the graph at x equals 1, it's going up 2 over 1, so we have 2 for that value. So we have -3 times 2, that'll end up giving us 4 on top. F of 1, if you just look at the y value when x is equal to 1, is 1. And then arctan of 1, if you think of your special right triangles, an angle who has a tan of 1 is 45, so that's why we have pi over 4 there. And you could have it where I have box there, or you could have either of those neatened up answers after it. Any of those are equivalent. On question 4, one thing to note is as this is draining, it's the radius is staying constant the whole time. So there's two ways you could have done part A. So this is a related rates problem. Start with v equals pi r squared h. You could have either done your derivative with respect to time and done a chain rule. So you got dv over dt, take your derivative of the r part, so 2 pi r dr over dt times the regular h, plus regular pi r squared times the derivative of h, which is dh over dt. Well, because the radius is constant the whole time, that dr over dt is 0 and wipes out the first term. Put 1 in for your radius in the second one and replace the dh over dt with -1/10. They had told us square root of h, but we're finding when h is 4, so we can fill that in, and that eventually gives us -pi over 5, and it's a change in volume, so we have feet cubed per second. Over to the right is the other way you can do it. Because the radius of 1 was constant the whole time, we can sub that in before taking the derivative. Then the derivative is a little neater. It's just dv over dt equals pi dh over dt. Sub in your negative 1/10 square root of h, but the h is going to be 4, and that gives you that same answer. So when the height of the water is 3 feet, the rate of change of the height of the water with respect to time. Is the rate of change of the height of the water with respect to time increasing or decreasing? So if your rate of change we want to know is increasing or decreasing, we got to go to the next derivative. So take your dh over dt, and we've got to do the derivative. So multiply the 1/2 out front. H will now be raised to the negative 1/2, and then times the dh over dt. Well, that h to the negative 1/2 goes to the denominator. Gh over dt can be replaced with the negative 1/10 square root of h. The square root of h's divide out, and when you multiply those together, you get 1 over 200 feet per second squared. Because that is positive, our rate must have been increasing. So separation of variables, we've got to solve the differential equation. So divide the square root of h over, multiply the dt over, and we've got to take the integral of both sides. Well, that's really h to the negative 1/2, so exponent goes up 1, divide by 1/2 out front, we get 2h to the 1/2. We'll have negative 1/10 t plus our c. We've got to fill in the 1 and the 5, so that sorry, not 1 and 5, 0 and 5. So that tells us that c is just 2 square root of 5. So replace the c, divide by 2, square both sides. We had to just be concerned that h couldn't be negative because that was under a square root in the original, but because in our final answer we are squaring everything, h will never end up being a negative. All right, that's it for the homework answers. Your other work today is to do the assigned problems. Have a great rest of your day.